Good morning. So moving on with our scattergraph topic, we're looking at interpolation and extrapolation. So first part of our lesson, we're just going to review how we plot scatter diagrams and how we draw in our lines of best fit. We'll talk a little bit about correlation again. We'll look at how we use our line of best fit to estimate values. And then we're going to look at the meanings of interpolation and extrapolation. What's the difference, and when is it good to interpolate, when is it good to extrapolate? Okay, so you have a worksheet attached to show my homework called Worksheet 1, and it should have this information on. Okay, so it's about 10 men who took part in a long jump competition, their heights and their best jumps. So you have a choice. You can print the worksheet off if that's possible, or you can copy the axes from here or the worksheet into your notebook, your school maths book, if you've still got room. Okay, so if we just look at the axes, okay, along the bottom we are plotting height, okay, and up the side we've got best jump in centimetres. So before I start plotting, I just want to check the scale. This is 150, this is 160, this is 170. So in between must be 155, here must be 165, and so on. So the scale is going up in tens, but each square is worth 5, so it's worth making a note of. Going up the side, we've got 420, 440, 460, and so on. So each square here is worth 20. So I've got to think about where 470 would be halfway, and then the others in between. Okay. So when we're plotting scatter diagrams, it's just like when we're plotting coordinates. Okay. The first numbers here are the height. And this bottom axis here is the height, so this is what I'm going to read across these numbers, and then the best jump are the numbers going up, so I'm going to read those numbers going up. So the first coordinate I'm going to plot is 180, 565, so I'm going to go along to 180, get my pencil, here's 180, I need to go up to 565, so that's 520, 540, 560. Now that's 570 in the middle, so 565 is going to be about a quarter of the way up, so about here. So I'm just using a dot. You can use a cross, but be very careful to keep your cross neat and tidy. You are marked for accuracy in the exams, so yeah, you're allowed to be half a square out, but the squares are quite small, so try to be as accurate as you can. So the next one is 174, 500. So again, I'm 174 going across. So this is 170, this is 175. So 174 is about here. And then we're going up to 500, which is here. Okay, another dot. Okay, 165, 488. So 160, 165. And then we've got 460, 480. Now that's 490 in the middle, we're just below that, so here. Okay, so that's all the points plotted now. Okay, so just looking at the general pattern is going in this direction, okay, which is telling me that higher men can jump further. Okay, so a very tall man can jump a lot further than a shorter man can. Okay, so that is what we learned last week, is positive correlation. Okay. All right, so this has got positive correlation. So now I'm going to get my ruler and I'm going to draw in a line of best fit. Now when we draw a line of best fit, we're trying to get the general direction, okay, so the general trend, it's going up, it's not going up really steeply, it's not going up sort of flat, it's going up in sort of this direction, and I want my line to sort of go through points if possible, but you sort of need to have the same number of points above and below the line. Now your line should not go beyond the set of points, so I shouldn't be drawing it up here and I shouldn't be drawing it down here. I need to sort of start where the lowest point is and go up to where the highest point is. So I think I'm going to try and get my line in there. I might adjust that a little bit. I can bring it that way a little bit. Okay. There we go. I think we've got 1, 2, 3, 4 points below, 1, 2, 3, 4, 5 above, but we've got the general direction. Now, just a point to note, your line may not be exactly the same as mine. You might be slightly higher, slightly lower, you might have tilted a little bit. That's not a problem. Okay, there's not, with a line of best fit, everybody's is going to be different. There's not one correct answer, but saying that, there is a boundary that you have to be between. So your answers will come out slightly differently when we do the estimating, but they should be fairly close to the answers that I get. Okay, it shouldn't be wildly different, but it's not necessarily going to be exactly the same. Okay, that was one of the things we picked up last week, that not everybody's line of best fit will be exactly the same. Okay, so now I want to use this line to do some estimating. So the first question says, use your line of best fit to estimate the height of a man whose previous best jump was 510 and the best jump of a man who is 185 centimetres tall. Okay, so if you want to have a go at that, press pause. If you're not sure, okay, carry on watching. Okay, so what we need to do, I'm going to choose a different colour. So his previous best jump was 510 centimetres. So I'm going to look at best jumps, which is this scale. I'm going to find 510. So this is 500, this is 520. We're halfway between. I'm going to draw a line across to my line of best fit, and then I'm going to read down here. So when we're estimating, you must draw these lines in. Okay, I might even just adjust that down a little bit because it doesn't look like it's halfway. There we go, that's slightly better. Okay, and then that goes there. All right, this is the working that the examiners are looking for, and it makes it really clear where you've been reading off. Okay, so if I read off here, I've got 150, 160, this is 170, that's 175, so I'm saying this is 172, okay, just below that halfway mark. So the man whose best jump was 510 is probably around 172 centimetres tall. Now you may have got that answer, you may have got slightly lower, slightly higher, okay, doesn't matter. But the point here we're trying to look at today is that I have got a point, estimated a point here that is between two other points. So there's points here and points here. Okay, my point is in between points that we know are true. Okay, so my estimate is likely to be a fairly good estimate because I'm in between other points here. Okay, so this is what we call interpolation. Okay, I've done an estimate, but it's on the line between other points, in between other points. If I wanted to see the best jump of a man who is 185 centimetres tall, okay, so this time I know the height, so I'm going to start with the height. So here's 185, so again I'm going to go up to 185 and read across. Okay, so this is 560, 570 is halfway. I would probably say that's 578 centimetres. We're just below 580. So it's either 577, 578, somewhere around there. Okay, we haven't got a very accurate scale, so again, we're not going to get exactly the same answers, but we read the best we can. Okay, so I've got 578 centimetres. So So again, this is known as interpolation. Okay, so we've had 2 readings that were interpolation because they were readings or estimations between points that we'd already plotted. So this one was between these points here, and this one was between this point here and these ones down here. So the last question says, why would it not be sensible to estimate the height of a man who can jump 700 centimetres? So if we look at our scale, actually our scale doesn't go up to 700, but we can see if 620 is there, we'd have 640, 660, 680, 700. We're talking somewhere up there. So if I extended my line, okay, let's just use some dots there. I know I've got blue. We're talking, so we've got 620, 640, 660, 680, 700. So somewhere over here. Now that's going to read off a height of well over 200 centimetres, okay, 210, okay, which is going to be incredibly tall. Okay, over 2 meters tall, very unlikely. And actually, people might be jumping a lot higher, but there is a limit to how tall people are going to get. So at some point, this is not going to be, this pattern here that we've got that's linear is not going to continue. It might be that it continues and then does something like that, sort of curves round, okay, or we might just end. But you can't just keep estimating and extending your line. So if we were just to extend our line and estimate, this is called extrapolation, but there's a lot of dangers in there because we don't know what's happening over here. Okay, so we've had interpolation and extrapolation. So we've got the definitions here. So interpolation is when we estimate in between 2 or more points. Okay, so interpolation is in between points. So that's within our range of data. Okay, extrapolation is estimating by extending the line. I had to make my line longer to be able to estimate. Okay, so that's outside the range of data. So just something to note, and I would put all of this in your notes, we need to be very careful when extrapolating as we cannot assume the pattern continues in the same way. So our scatter diagram is showing us a sort of pattern, okay, a definite trend, but we only know what's happening for the points that we've got in the range that we've got, okay. We can't make the, it's very difficult to make the line longer and assume the pattern continues. So general rule is that we avoid extrapolation whenever possible. Can't always, but if we are going to extrapolate, we need to be aware that there are problems with it. Okay, so press pause, get all of that in your notes. As we said, the title is Interpolation and Extrapolation, so you really need to understand the difference between the two. Okay. So the next activity, and you can complete this and send this in for me to look, is just to match the terms with the correct definitions. So we've got all the terms here, some from last lesson, some from this lesson, and lots of different definitions here. Can you match them up? So for example, correlation. Well, if you remember, correlation is when we're talking about 2 pieces of data that have a connection. Okay, so if we have, there we go, a connection between 2 variables, that's what we're talking about. Okay, so let's just join that, a connection between 2 variables. So I can join it like that, or if you want to, you can print this off. I'll attach it to show my homework and cut them out and stick them together, and it's entirely up to you, or you can just copy them out with the correct definitions. Okay, so press pause and finish that off, get all the definitions matched with the correct words. Okay, so the last thing we're going to do this lesson is just put everything we've done into practice. I've got a couple of questions to do. So again, you can either print the worksheet off, okay, and complete it, or you can copy these axes into your notebook. So on the worksheet, the axes aren't drawn for you, you've just got a grid. So on here I've given you a suggestion. So for this one we're looking at the height of men and their shoe size. So this one, height, the first one that we read across the top should normally go across the bottom. So I've got height in centimetres and I've started at 160 here and I'm going up in 2. So I've got 162, 164, 166, 168 and then 170 and so on. And then the second line is shoe size and that goes up the side. And I needed to go from 8 to at least 13. So I've gone 8 and then 2 squares 9, 2 squares 10 and so on. Okay, so get that copied, plot these points, draw in a line of best fit, okay, and then you need to answer the questions at the bottom of the worksheet. So if you've not got the worksheet in front of you, just press pause, okay, while you get that done. And here are the questions. So you're asked to estimate the height of somebody with a shoe size of 10.5 and then say whether that's interpolation or extrapolation that you've used. If a man has a height of 190 centimetres, what would his predicted shoe size be? And again, is that interpolation or extrapolation? If a man has a shoe size of 14, what would his predicted height be? Is this interpolation or extrapolation? Okay, and just as an extension, can you say out of those 3 estimates, which one's the most reliable and which is the least reliable and why? Okay, so get that one done and then we'll look at question 2. So question 2, we're looking at minutes exercising against resting heart rate. Okay, so again, minutes exercising is the top row of the table, so that should go along the x-axis. And again, look, I've labelled it here, minutes resting, and resting heart rate should go up the side. And again, I've got a label there. So minutes resting, I've gone up in 20s, 20, 40, 60, 80, 100. Okay, and I needed to go up to 300. And resting heart rate, I've gone up in 2, so I've got 52, 54, 56, 58, 60, and I've gone up to 70. So again, plot these points here onto your grid, okay, and then when you've done that, draw in a line of best fit, try and make sure you get the general trend in the right direction, try and go through as many points as you can, but have the same number above and below if you can. Okay, when you've got your line of best fit in, okay, you might want to think about whether it's positive or negative correlation, and then have a go at these questions here. So again, a person has a resting heart rate of 52. How many minutes a week would you predict that they exercise for? And then say whether that was interpolation or extrapolation. If a person does no exercise, what would you predict their resting heart rate to be? I'm just going to change that because that should be exercising. Okay, so no exercise is going to be 0 minutes. So think about what happens there and do interpolation or extrapolation. And if a person exercises for 30 minutes per week, what would you predict their resting heart rate to be? Again, interpolation or extrapolation. And again, which is the most reliable and which is the least and why? So press pause and get those 2 questions completed and all the predictions made. Okay, so this is question 1. Okay, so the points are plotted here. So we've got positive correlation because the points are going in this direction, which is my red line. Okay, which means the taller the man, the greater his shoe size. So a tall man will have a large shoe size, a shorter man will have a smaller shoe size. Okay, so again, your line might not be exactly in the same place as mine, and your answers might not be exactly the same as mine, but they should. So, reading from my graph, a shoe size of 10.5, well here's 10.5, if I read across and come down, I get 175 centimetres. Now this here is in the middle of my points, it's within my range, it's between some points, so this is interpolation. Okay, we'll come to the reliable bit in a minute. Okay, question 2, if a man has 190 centimetres or a height of 190 centimetres, what's his predicted shoe size? Well, here's 190. I've gone up to the line, but I've had to extend my line here because it wasn't long enough. So this is the purple bit, and then I've read across. Now it's sort of between 14 and 14.5, so you'd have to get the bigger shoe size. So I've gone for 14.5 because you can't have 14.25. Okay, and the last one was if a man has a shoe size of 14, what would be his height? So I've started at 14, I've gone back, but again I've had to use the extended bit of the line and come down, and it's 182, 184, 186, 188. It's about 189 centimetres. Okay, so these last two were both extrapolation because I had to extend the line of best fit and use that to make my predictions. Okay, so they're outside the range. So which is the most reliable, which is the least? So if you've interpolated, that is always the most reliable because you're within your range. So the first one is definitely the most reliable. The least reliable is the one that's the furthest along that extended line. So this one here of 190 is further away from the data than this one when we were looking at a shoe size of 14. Okay, so the least reliable one is number 2, and number 3 is sort of between the two. It's still not reliable, but it's better than number 2. Okay, question 2 then. So this one was minutes exercising and heart rate, and this set of points is going in the other direction. So this is negative correlation. So, and it's quite strong actually because the points were quite close together, certainly here. These two are a little bit further away, but other than that, my line is pretty much going through them. So it's quite strong negative correlation, which means as the minutes exercising increase, the resting heart rate decreases. So exercising a lot will bring your resting heart rate down. Exercising a little will mean you've got a high resting heart rate. Okay. So if a person has a resting heart rate of 52, how many minutes exercising would you predict they exercise for? So here's 50, 52, read across and down. Okay, we've got 220, 240, 260. It's going to be about 270 minutes. Okay, and again, this is interpolation because it's between some points here. And just note my line of best fit starts at the lowest point and goes up to the highest point. Okay, so our line of best fit should only be for the points we've plotted. Okay, so that's interpolation. Number 2, if a person does no exercise, what would you predict their resting heart rate to be? Well, no exercise means 0 minutes. Now my line didn't go up, so I've had to extend my line. Okay, and 0 minutes suggest a resting heart rate of about 76, between 75 and 76. Okay, so I've put 76 here, and that's extrapolation. I've had to extend my line. And number 3, if a person exercises for 30 minutes, what would you predict their resting heart rate to be? So 30 is around here. So if I again go up, okay, and read off, that's coming out at about 73 as the resting heart rate. But again, I've had to use the extended part of the line, so that's also extrapolation. So I've got an interpolation and 2 extrapolations. The most reliable, again, interpolation is always the most reliable way of predicting. The least reliable has got to be this number 2 when there was no resting heart rate. Okay, partly because again it's further from the data, but also Again, we can't assume that this bit's going to be linear. Okay, there might be some other pattern going on the fewer minutes you exercise. Okay, but 30 minutes, okay, is closer to the set of data than 0 minutes. Okay, there we go. So hopefully you've got a good understanding of what interpolation and extrapolation is, and for those of you who are struggling with the correlation, we've had a good and scatter diagrams, we've been able to revise that a little bit as well.